Might be a little challenging at first. We have a composite solid here, but instead of solids being added to each other to make a larger composite solid, this composite solid is a larger solid with a solid shaped hole in it. So instead of adding our volumes at the end, we're going to subtract the volumes at the end. All right, think of this as a paper towel roll. All right, and what we're going to do is find the volume of the larger cylinder, pretending that it's all the way filled in, so pretending like there's no hole in it. We'll find that total volume, and then we'll find the volume of the cylindrical hole, and we will subtract those two values to get the paper towel volume. All right, let's see what we got here. Still, we follow the same steps. We're going to name the shapes. So I'm just going to call this large cylinder, small cylinder. And we're going to get the area formulas down. Step 2, write the formulas. So that's not area. I'm doing that in 7th grade. Volume, pi r squared h. Same thing for the small cylinder. That's going to be pi r squared h. Now we have to plug in the dimensions. That's step 3. So plugging in our dimensions for this, the volume of the larger cylinder, we're going to use 3.14 for our approximation for pi. Our radius, they give us actually the diameter of 12, so we got to plug in a radius of 6, and then we have the height, which is always perpendicular to the base of the shape, so that's going to give us 26. Let's plug in the other ones while we're at it. 3.14, I always forget to change that to the approximately symbol. We're going to then find, it looks like that is all the way across. 4.2 is the diameter, so we need to change it to 2.1 to calculate the radius. And then we're going to find the height of that, which is the same as the height of the other cylinder. Now we're going to ask our calculator for some help. First one we're going to do is 3.14 times 6 times 6 times 26, and that gives us 2,939. 2,939.04 is the volume, approximately. The approximate volume over here is 3.14 times 2.1 times 2.1 times 26, and that gives us 360.0324. 360.0324. And like I said, we are going to be subtracting these because the small cylinder is actually a hole in the middle of this large cylinder. All right, so we have to subtract that volume to get the volume of just the outer layer of that paper towel roll. All right, so let's get our calculator going again. 2,939. So we got 2,939.04 minus 360. Minus 360.0324. And our final answer is going to come to 2,579.0076. I said in the previous problems that we're going to round to the nearest tenth, and we're going to continue that. So that looks like it rounds to 0.0. So 2,579. 2,579 and 0 tenths. And then our correct unit is centimeters cubed. All right, what did we do at the end there? We subtracted the volume of the larger item minus the volume of the hole in that larger item. All right, so there's a great example of a composite figure with a subtracting subtracting the volumes. All right, here's one that we're going to practice later, but I want to, in this subtraction part, zoom down here. All right, here is one with a hole. It's kind of like a bowl-shaped hole. You have to decide what shape that is, And you're going to try this one on your own. I'll give you the shapes, I'll get you started, and then you guys can figure out how to calculate the volumes and then how to get your final answer through subtraction. All right, so we have a rectangular prism, and then we have a half of a sphere, also called hemisphere. All right, and then so you're going to pause it. You're going to try your best to get it right, and you're going to plug in your value into this program and then see if you got it right. If you don't get it right, then you're going to explain where you went wrong. You're going to analyze your work and figure out what messed you up and learn from that mistake. All right? So pause it and get going. Now you're back. So, oops, I have to find the appropriate formulas. Appropriate formulas for a rectangular prism would be capital B times H, which that B is just the area of the base, so that's length times width. Just multiply those dimensions. So that's going to give me 10 times 10 times a height of 13. So that gives me 100 times 13 is going to be 1300. There's my volume of that rectangular prism. Now I need to find this half of a sphere or hemisphere, and my volume formula for a sphere is volume equals 4/3 pi r cubed, and since I'm doing half of a sphere, I'm going to multiply that answer by a half. I could also divide the whole thing by 2. Let's fill in the numbers. So I can just, why don't I simplify these fractions and just do 4/6, or I could do 2/3 as well, but times 3.14 times, now this is, what is the radius here? That's tricky. It looks like this circle extends all the way across, right? It's just as wide as this rectangular prism. So if it goes from edge to edge there, well, what is that distance? We look down here, that distance is 10. So we don't want all the way across of 10, we just want 5 for the radius. So that's going to be 5 right there. All right, now it's time to ask our calculator for some help. All right, that's going to be 4 divided by 6. We're going to multiply that by 3.14 and then 5 cubed. So times 3.14 times 5 times 5 times 5. And that gives us 261.66666666, which gives us 261.7 if we round to the nearest tenth. Right? Yeah. 261.7 approximately. All right, so what are we going to do with these two values? Well, since the hemisphere is a hole in the larger solid, then we're going to subtract it from that larger solid's volume. All right. All right, wow. My pen's not writing all that well down here. Okay, 1038.3, and what type of units? It's going to be cubic units, centimeters cubed. All right, so find your mistakes, write those, or describe those things in the Edpuzzle little question, and we'll try to learn from it and move on. All right, good luck.